Download this code from codegive.com, link in the description below. Complete Godot version control workflow with Git. This tutorial provides a comprehensive guide to using Git for version control with Godot engine, covering everything from initial setup to advanced branching strategies and common pitfalls. It's designed to be helpful for beginners and experienced Git users alike. Why use version control with Godot? Version control, especially with Git, is essential for any serious game development project. It offers numerous benefits. Collaboration allows multiple developers to work on the same project simultaneously without overwriting each other's changes. Tracking changes provides a detailed history of every modification made to the project, making it easy to revert to previous versions or understand the evolution of the code base. Experimentation enables developers to try out new ideas and features in isolation, using branches, without risking the stability of the main project. Backup and recovery serves as a robust backup system, protecting against data loss due to hardware failures or accidental deletions. Code review facilitates code review processes, ensuring code quality and catching potential bugs early. Conflict resolution helps resolve conflicts when multiple developers modify the same files. Remote collaboration allows collaboration with developers located anywhere in the world through platforms like GitHub, GitLab, or Bitbucket. 1. Setting up Git and choosing a repository host ****. Install Git ***. Windows download and install Git for Windows from https://gitscm.com/download/win, https://git-scm.com/download/win. Mac OS If you don't already have it, the easiest way is to install Xcode command line tools, Xcode select install. Alternatively, download from https://gitscm.com/download/mac, https://git-scm.com/download/mac. Homebrew, package manager, also works. Brew install Git. Linux use your distribution's package manager, example sudo apt-get install Git on Debian/Ubuntu, sudo yum install Git on Fedora/CentOS. Configure Git open your terminal or Git bash and set your username and email address. You might also want to configure a default text editor for commit messages. Choose a repository hosting service GitHub most popular, offers free public repositories and paid private repositories. Good for open source projects and teams. GitLab offers free public and private repositories with unlimited collaborators. Provides integrated CI/CD, continuous integration/continuous delivery, tools. Bitbucket offers free private repositories for small teams, up to 5 users, and paid plans for larger teams. Self-hosted You can also host your own Git server, example using GitLab Community Edition, if you require maximum control and security. Create an account on your chosen service and create a new, empty repository. Do not initialize the repository with a README, license, or any other files, we will do this locally. Take note of the repository's URL, example https://github.com/your username/your project name.git. 2. Initializing the Git repository in your Godot project ***. 1. Navigate to your project directory ***. Open your terminal or Git bash and navigate to the root directory of your Godot project. 2. Initialize the Git repository ***. This command creates a hidden .git directory in your project folder, which is where Git stores all the version control information. 3. Creating a .gitinerary file ***. Crucially important for Godot. A .gitinerary file specifies files and directories that Git should not track. Ignoring unnecessary files prevents your repository from becoming bloated and avoids committing temporary files or user-specific settings. 1. Create the .gitinerary file ***. 2. Populate the .gitinerary file ***. Open the .gitinerary file in a text editor and add the following rules, at a minimum. Explanation ***mono build artifacts, if you're using C. ***xproj.sln, C project files. *_import/ imported assets. This folder contains converted assets and is usually large and not portable. Important ***, if you're using Godot 4's resource database, you may need to manage the import files and include them. See section 8 later on. *bin/, compiled binaries. *export_presets.cfg, contains export settings, which may include sensitive information. *godot/, contains Godot editor configurations and settings. ***translation, translation files. ***import, temporary import files. ***cake, cache files. ***tmp, temporary files. ***, backup files. ***vscode/, VS Code project files. ***ds_store, .apple, Mac OS system files. *thumbs.db, $recycle.bin/, Windows system files. ***end, /gitinerary, ignores all hidden files and folders except for the .gitinerary itself. This is to prevent things like .godot_state from being tracked. *log, .tmp, .exe, .dll, .so, .stex, generic files and folders that we never want to track. Customize .gitinerary ** adjust the .gitinerary file to include any other files or folders that are specific to your project and should not be tracked. 4. Staging and committing your project ***. 1. Add files to the staging area ***. The staging area is where you prepare the changes you want to commit. This command adds all untracked files in your project to the staging area. Review the output carefully to ensure you're not adding any files that should be ignored. Use Git status to check what will be added. If necessary, you can selectively add files. To commit your changes ***. A commit is a snapshot of your project at a specific point in time. **M specifies the commit message. Write clear and concise commit messages that describe the changes you've made. Good commit messages are crucial for understanding the history of your project. 5. Linking your local repository to the remote repository ***. 1. Add the remote repository ***. Replace your _repository _URL with the URL of your repository on GitHub, GitLab, or Bitbucket. Example https://github.com/your username/your project name.git. Origin is a conventional name for the remote repository, but you can use a different name if you prefer. 2. Push your local changes to the remote repository ***. Git push sends your local commits to the remote repository. *U origin main sets the upstream branch for your local main branch. This means that subsequent git push commands can be simplified to just git push. Main may be called master in older repositories. You might be prompted to enter your username and password or configure SSH keys for authentication. 6. Basic Git workflow ***. This section outlines the typical workflow for making changes to your project and pushing them to the remote repository. 1. Make changes ***. Modify your Godot project files as needed. 2. Check the status ** use git status to see which files have been modified. This helps you track your changes and ensure you're not missing anything. 3. Stage changes * use git add to add the modified files to the staging area. 4. Commit changes * use git commit to create a new commit with your changes. 5. Push changes * use git push to send your commits to the remote repository. 7. Branching strategies ***. Branching is a powerful feature of Git that allows you to work on different features or bug fixes in isolation without affecting the main code base. * creating a branch *. This creates a new branch named feature/new enemy. * switching to a branch *. This switches your working directory to the feature/new enemy branch. You are now working on a separate copy of your project. You can also create and switch to a branch in one step. * making changes on a branch * make your changes, stage them, and commit them as usual. * merging a branch * once you've finished working on your feature or bug fix, you can merge the branch back into the main branch, example main. 1. Switch to the main branch. 2. Merge the feature branch. If there are no conflicts, Git will automatically merge the changes. If there are conflicts, you'll need to resolve them manually, see the conflict resolution section below. 3. Push the changes to the remote repository. 4. Delete the feature branch, optional. * common branching models * git flow * a more complex model with multiple long-lived branches, example main, develop, feature/, release/, hotfix/*. Suitable for larger teams and projects with well-defined release cycles. *GitHub flow * a simpler model that relies on short-lived feature branches that are merged directly into main. Suitable for smaller teams and projects with continuous deployment. *GitLab flow * a more flexible model that combines elements of Git flow and GitHub flow. Choose a branching model that fits your team's size, project complexity, and release strategy. 8. Godot for resource management and .gitinery ***. Godot 4 introduced significant changes to the resource management system. The key difference is that import settings are stored in .godot/imported instead of the _import folder. This means you might want to include the imported files in your Git repository to ensure consistency across different machines or when collaborating with others. Here's how to handle it ***. Option 1, track imported resources, recommended for team projects. * modify your .gitinery file to exclude the .godot/imported directory. Remove .godot/imported from .gitinery. * consider only tracking the important metadata files in the .godot folder. This minimizes noise and avoids tracking temporary files. Option 2, re-import on each machine, suitable for single developer. Keep .godot/imported in .gitinery. The downside is that each developer will need to re-import assets on their machine, which can take time. The best option for you depends on your project's needs and your team's workflow. 9. Conflict resolution ***. Conflicts occur when Git cannot automatically merge changes from different branches. This usually happens when multiple developers modify the same lines in the same file. 1. Identify conflicts * when you try to merge a branch, Git will tell you if there are any conflicts. It will mark the conflicting sections in the affected files with special markers. To resolve conflicts, open the affected files in a text editor and manually resolve the conflicts. Decide which changes to keep, modify, or combine. Remove the conflict markers, ========================================================================================================================Commit the resolved file *. Repeat this process for all conflicted files. 4. Continue the merge *. Once all conflicts have been resolved, continue the merge process. 10. Useful Git commands ************ Git status shows the status of your working directory and staging area. ***git log displays the commit history. ***git diff shows the differences between your working directory and the last commit, or between two commits. ***git checkout switches between branches or reverts changes in your working directory. ***git reset resets the staging area or reverts commits. ***git revert creates a new commit that undoes the changes made in a previous commit. Safe way to revert changes. ***git branch lists, creates, or deletes branches. ***git merge merges changes from one branch into another. ***git pull fetches changes from a remote repository and merges them into your local branch. ***git push sends your local commits to the remote repository. ***git fetch downloads objects and refs from another repository. Does not merge changes. ***git rebase integrates changes from one branch into another by rewriting the commit history. ***git stash temporarily saves changes that are not ready to be committed. Useful for switching branches without committing unfinished work. 11. Godot specific considerations ******* scenes and resources Godot scenes and resources are stored as text files. This allows them to be easily versioned with Git. Be mindful of large textures and audio files, as they can increase the size of your repository. Consider using Git LFS, large file storage, for very large binary files. **project settings Godot's project settings are stored in the project.godot file. This file should be versioned. Godot editor configuration as mentioned earlier, the .godot directory contains editor-specific settings. You can choose to version these settings or ignore them, depending on your team's preferences. 12. Advanced tips and best practices commit frequently make small, focused commits with clear commit messages. Use meaningful branch names choose branch names that accurately reflect the purpose of the branch, example feature / new enemy, bug fix / collision detection. Keep your branches up to date regularly merge or rebase your feature branches with the main branch to avoid merge conflicts. Code review use pull requests and code reviews to ensure code quality and catch potential bugs. Use Git hooks automate tasks such as code formatting, testing, or commit message validation using Git hooks. Learn Git tools explore Git GUI tools like Git Kraken, SourceTree, or Tortoise Git to visualize your Git repository and simplify common tasks. Online courses and documentation there are many excellent online courses and documentation resources available for Git. For example, the official Git documentation, https://gitscm.com/doc, https://git-scm.com/doc, is a comprehensive resource. Atlassian's Git tutorials, https://www.atlassian.com/git, https://www.atlassian.com/git, are also very helpful. Code example, GD script. This is a very simple example, but it shows how code should be managed within your Git repository. Make sure to add this file, e.g. player.gd, to your Git repository as described earlier using git add and git commit m added player movement script. Common mistakes to avoid asterisk. Asterisk committing large binary files. Asterisk avoid committing large binary files, example large textures, audio files, directly to your Git repository. Use Git LFS or store these files in a separate asset management system. Asterisk committing sensitive information. Asterisk never commit sensitive information, example passwords, API keys, to your Git repository. Use environment variables or secrets management tools instead. Asterisk ignoring files that should be ignored. Asterisk carefully configure your .gitinerary file to exclude unnecessary files and directories. A badly configured .gitinerary can lead to a bloated repository and conflicts. Asterisk committing incomplete or broken code. Asterisk avoid committing incomplete or broken code. Only commit code that is working and has been tested. Asterisk pushing directly to main. Asterisk avoid pushing directly to the main branch, especially in larger teams. Use feature branches and pull requests instead. Asterisk forgetting to pull before pushing. Asterisk always pull the latest changes from the remote repository before pushing your local commits to avoid conflicts. By following this comprehensive tutorial and adopting good Git practices, you can effectively manage your Godot projects, collaborate with other developers, and protect your valuable work. Remember to experiment, learn from your mistakes, and adapt your workflow to suit your specific project and team needs. Good luck.